Here is a finalized corporate strategy memo. The business, a company named BlendStack, has been presented with a $12 million all-cash acquisition offer. The document outlines specific, concrete terms. The executive board voted 5-1 in favor of the sale, stipulating a $1.5 million retention earnout. It also logs a precise dissenting opinion from one board member, who argues the company should reject the offer due to 5 quarters of unaddressed, decelerating growth. Move past simple code generation and into the realm of deterministic strategic decision-making. Standard command line agent tools and chat interfaces fail at complex problem-solving. A single open-ended prompt window lacks the rigidity required to force an AI model to evaluate competing priorities over time. Relying on these out-of-the-box platforms traps engineers in a normal distribution of average AI outputs. When the system has no structural constraints, it generates the most statistically likely generic response. The gold standard for strategic output is the high-density executive memo popularized by top-tier tech CEOs. These rely on verified facts, rigorous debate, and clear constraints. To replicate that quality in code, we have to build a primary pipeline: uncertainty in, decision out. Constructing this pipeline requires 3 distinct pillars: custom agent harnesses, the 1 million token context window, and adversarial orchestration. To pull AI into high-leverage strategy, engineers must stop typing prompts into chat windows and start building dedicated architectural environments. The first pillar is the custom agent harness. An agent harness is a tailored software wrapper that controls an AI model's inputs, outputs, and execution logic natively. Using an extension like Pi, the harness parses specialized front matter, the configuration data at the top of a file, to set the parameters before the system ever boots up. This system explicitly rejects conversational prompts. If an operator tries to chat with it, the code won't execute. Instead, the harness requires a strict input template known as the brief. It forces the operator to define 4 mandatory parameters: context, stakes, constraints, and key questions. Missing any parameter instantly rejects the file, forcing the operator to clarify their logic first. The harness also enforces hard-coded financial and temporal constraints. The system is programmed with strict dollar-amount compute budgets per decision, ensuring the agents stop deliberating once they hit a specific spend limit. A specialized harness removes human error from prompt engineering. It transforms chaotic, open-ended AI chats into a strict, verifiable data ingestion process. Once the brief is accepted, it moves into the multi-agent graph, starting with a central CEO node that ingests the problem. The CEO node then broadcasts the complete brief to a perimeter of specialized board member nodes. This uses a parallel execution model. All board members process the CEO's prompt simultaneously, forming their own independent opinions without blocking one another. The historical technical hurdle for this kind of architecture has always been data limits. Feeding entire business metrics, product overviews, and historical expertise files to multiple agents simultaneously was cost prohibitive. The catalyst making this possible is the 1 million token context window available in models like Anthropic's Opus and Sonnet. A token is a basic unit of text, like a syllable, and the context window is the total amount of data the AI can hold in its working memory at one time. Flat pricing for the full context window removes the traditional incentive to compress data, altering the core approach to architectural design. To function efficiently, these models must maintain high retrieval fidelity past the 250,000 token mark. This metric defines how accurately an AI locates specific facts buried deep within a massive dataset, allowing every agent to load massive auxiliary files and accurately recall them during the debate. A 1 million context window provides the economic unlock required for parallel agents to share persistent, hyper-specific domain expertise without performance degradation. Each board member node is driven by a unique system prompt. A revenue agent is programmed to prioritize cash collection within 90 days, while a compounder agent is instructed to focus strictly on multi-year competitive advantages. The most critical node is the outlier persona, the moonshot agent. This agent's prompt explicitly instructs it to reject safe, incremental bets and fiercely advocate for category-defining risks. This creates a highly deliberate adversarial dynamic inside the system. These independent agents are specifically engineered to disagree with each other. As the debate cycles, individual agents maintain specific expertise files to track the biases, compromises, and historical arguments of the opposing board members. This internal board conflict forces the agents to attack the logic of the initial brief, exposing hidden flaws and contradictions in the business's own mental model. Orchestrating adversarial agents guarantees that a strategy is aggressively stress-tested against diverse, optimized viewpoints before a single dollar of actual capital is deployed. Left unchecked, a multi-agent debate could run in an infinite loop, constantly generating counterarguments without ever reaching a conclusion. To solve this, the custom harness actively monitors the runtime. Once the predefined budget or time constraint is met, the code injects a hard stop command into the loop. This triggers the CEO node's final protocol. It forces final closing statements from the board, synthesizes the resolved and unresolved tensions, and outputs the final markdown memo. Because this relies on rigid structural logic rather than specific content, the pattern scales directly to entirely different crisis scenarios. If the company suddenly receives a warning letter from the FDA, the engineer simply drafts a new brief, injects the regulatory code into the context window, and boots the same exact boardroom to navigate the crisis. Hard-coded orchestration constraints prevent infinite execution loops, forcing abstract AI debates into concrete, actionable artifacts, regardless of the domain. This progression moves from standard prompt engineering through agentic coding and into the more complex discipline of agentic engineering. Modern development increasingly involves building the systems that build the systems. High-leverage AI utilization prioritizes architecting the digital executive teams that specify exactly what needs to be built.